In this video, we're going to learn how to balance chemical equations. We've already discussed chemical equations. They are a way for us to write out a chemical reaction. We've also discussed the law of conservation of mass that says if you have a certain number of atoms of an element going into a chemical reaction, you have to have the same number coming out, or that the number of atoms of each element have to be equal in both the reactant on the left side of the equation and in the product, or the right side of the equation. We can fix unbalanced equations, and we're going to practice that. Please pay close attention so that we can avoid some of the most common mistakes. In this chemical equation, we have the reactant, which is water, and over here, H2 plus O2. When you first see a chemical equation, the very first thing you should do is draw a line so that you have a visual separator between the reactant and the product. And then we're going to make a list of the elements that exist on both sides. In this case, we have oxygen and hydrogen on both sides. And notice that I'm going to make the list in order so that I can compare them easily to determine if they're balanced and what I need to do to fix that. Over here, we have our subscript of 2 after our hydrogen. So I know I have 2 hydrogen atoms. And because there's no subscript here, I know that there is 1 oxygen. Over here, a subscript of 2 and a subscript of 2. So in this case, this is an unbalanced equation. We have a problem right here. This is telling us that in the process of a chemical reaction, we gained an atom of oxygen, and that's not possible. But we can fix that. In order to fix that, the only thing that you can do is change the coefficient. The coefficient is the large number in front of each compound. In this case, they are all 1 right now because we can't see them. They're ghost ones. But you can change them to any number that will help you to get equal numbers of atoms of each element. So I know that I need more oxygen on the left-hand side or in the reactant. The only thing I can do is change the coefficient. Right now it's 1, but I need to have 2 oxygens. So in order to do that, I can't stick a number in the middle of this compound. This compound is one thing, it stays together. So I'm going to place a 2 as my coefficient. And then I have to apply that coefficient to everything in that compound. So 2 times 2 gives me a total of 4 hydrogen atoms now. And 2 times 1 gives me a total of 2 oxygens. So I fixed my oxygen, but now I've caused myself another problem with hydrogen. I now have 4 hydrogens on the left, but only 2 on the right. And again, the only thing I can do is change the coefficient. In this case, I'm going to change the coefficient so that I end up with a total of 4. I need to multiply this subscript by something to give me 4 hydrogens, and that's going to be 2. And now I have a total of 4. And now this equation is balanced. I do want to address one thing before we go on to the next example. A lot of times people make the mistake of wanting to change the subscript, and that's not allowed. This is why. So if I needed to have 2 oxygen atoms, instead of changing the subscript, I have to change the coefficient. And the reason for that is this is a molecule of water. When I change the subscript, it's no longer water, it becomes hydrogen peroxide. And that's not what we're trying to do. We're not trying to change the substance. We're trying to change the number of atoms. By instead placing a coefficient in the front, I've given myself 2 molecules of water. So I've just increased the amount of water that I have, but it's still the same substance. Hopefully that makes sense. Now we're going to try another one. Again, the very first thing you should do is draw a line to separate your reactant from your product, and then we're going to make a list of all of the elements that exist on both sides. We have carbon, hydrogen, and oxygen. And again, carbon, hydrogen, and oxygen. On this side, we have no subscript and no coefficient, so we have 1 carbon atom. We have a subscript here of 4, so we have 4 hydrogens, and here we have a subscript of 2. On this side, we have 1 carbon, 2 hydrogens, and 2 plus 1 gives us 3 oxygens. So we have a problem. We actually have a couple of problems. One is with hydrogen and one is with oxygen. So we have more hydrogen on the left than we do on the right. We need to increase the amount of hydrogen that we have on the right-hand side or in the product. I'm going to put some little lines here to show me where I can change my coefficients. So I'm going to go ahead and try to get 4 hydrogens over here just to make them match. If I want to have 4 hydrogens, I need to multiply this subscript by something to give me 4, and that's going to be 2. But this 2 as the coefficient applies to everything in the formula. So we have to multiply for hydrogen and for oxygen. So we have 2 times 2 gives me 4 hydrogens. 2 times 1 gives me 2 oxygens, but don't forget there are also 2 here. So I have 2 plus another 2 gives me 4 oxygens. So I fixed my hydrogen problem. I did not fix my oxygen problem. So now I'm going to come over here and see what I can do. I have a total of 2 oxygens, but I need 4. Again, I'm going to place a 2 in the space for the coefficient, and that gives me 2 times 2, 4. So now we have carbon, 1 on both sides, hydrogen, 4 on both sides, and oxygen, 4 on both sides. Now this is a balanced equation. We've fixed it. Now we're going to try one that's a little bit slightly more complicated. We're going to draw our line and we're going to make our list. Ag is silver, N is nitrogen, O is oxygen, and Cu is copper. I'm going to make that list on both sides just like I have before. Over here, there's no subscript and no coefficient. I have 1 atom of silver. Nitrogen, no subscript, gives me 1 atom of nitrogen, 3 of oxygen, and 1 of copper. Over here, we have 1 silver atom. Nitrogen, we have parentheses. So we have to figure out what that parentheses means. If you have a subscript, which you always will, outside of the parentheses, that subscript applies to everything inside the parentheses. In this case, we're going to multiply this subscript by the ghost 1 that's already next to nitrogen, and that gives us a total of 2 nitrogen atoms. Oxygen, same thing. This 2 on the outside of the parentheses also applies to the oxygen because it goes with this compound completely. We have 2 times 3 gives us 6 oxygens, and copper, we have only 1 because this subscript does not apply to the things outside of the parentheses. So our copper matches, our oxygen doesn't, our nitrogen doesn't, and our silver does. So we have to increase the amount of oxygen we have on this side. We have 6 in the product and we only have 3 in the reactant. So we can increase that by changing, again, the subscript, or the coefficient. We're going to put our lines there to remind us where we can actually make a change. So if I want to have 6 oxygens on this side, I can't stick anything inside the compound and I can't change the subscript. I have to put a coefficient in front of the entire compound. So in order to get this to increase to 6, I'm going to multiply it by 2. But then we have to change the numbers of atoms for everything in that compound. So 2 times 1 gives us 2 atoms of silver. 2 times 1 gives us 2 atoms of nitrogen. 2 times 3 gives us 6 atoms of oxygen. And We fixed our oxygen. We still have matching copper. We now have matching nitrogen, but we don't have equal numbers of silver on both sides. So we have to fix that. We have more on this side than on this side. So this is the side we have to work on. We're going to increase the number of silver atoms. If I wanted to change this, we already have 1 atom of silver. So I'm going to place a 2 here, multiply it by the ghost 1, and I end up then with 2. So now we have 2, 2, 2, 2, 6, 6, 1, and 1. So that is now balanced. Hopefully this makes sense to you.